Hello. Welcome to Camellia Cafe. I'm BB8. What would you like?
I'm R2D2. I want a cup of Litz.
I'm R5D4. I want a cup of espresso.
Don't forget me. I'm 3PO. I want a cup of mocha.
Just enjoy your coffee, and I will introduce myself from following questions. What's my structure? How does my body move? How does my head turn? How to remote control me? And how to charge me? BB8 is a spherical droid with a free-moving domed head. She's cute. She knows that she can win people over. A lot of parts are in my body.
Head. Magnetic head rollers. Head arm top with magnetic rollers. Head rotation motor. Head arm angle servo. Head support or control arm. Motor and own wheels. Base plate with Segway control system.
BB8's body rolls independently from the head, which always stays near the vertical axis of the droid. The robotic ball uses a gyroscope to determine which way is down, and 2 or 4 wheels to move the sphere from inside. The base plate, which includes batteries, serves as a counterweight to keep the wheels acting against the lower half of the sphere. There's also a vertical bearing that helps to keep the wheels in contact with the walls. Segway type control system. To move forward or backward on the Segway, the rider just leans slightly forward or backward. To turn left or right, the rider turns the right handlebar forward or backward. This balancing act is the most amazing, and it is the key to its operation. To understand how this system works, it helps to consider the device, the human body. If you stand up and lean forward, so that you are out of balance, you probably won't fall on your face. Your brain knows you are out of balance, because fluid in your inner ear shifts, so it triggers you to put your leg forward and stop the fall. If you keep leaning forward, your brain will keep putting your legs forward to keep you upright. Instead of falling, you walk forward, one step at a time. The Segway does pretty much the same thing, except it has wheels instead of legs, a motor instead of muscles, a collection of microprocessors instead of a brain, and a set of sophisticated tilt sensors instead of an inner ear balancing system. Like your brain, the Segway knows when you are leaning forward. To maintain balance, it turns the wheels at just the right speed, so you move forward. The primary sensor system is an assembly of gyroscopes. A basic gyroscope is a spinning wheel inside a stable frame. A spinning object resists changes to its axis of rotation, because an applied force moves along with the object itself. Inertial. The axis of rotation is free to assume any orientation by itself. When rotating, the orientation of this axis is unaffected by tilting or rotation of the mounting, according to the conservation of angular momentum. Gyroscope is useful for measuring or maintaining orientation. A typical airplane uses about a dozen gyroscopes in everything from its compass to its autopilot. The Russian Mir space station used 11 gyroscopes to keep its orientation to the Sun, and the Hubble Space Telescope has a batch of navigational gyros as well.
Gyroscopes is used as inertial navigation systems when magnetic compasses would not work.
A conventional gyroscope is a mechanism comprising a rotor to spin about one axis, the rotor being mounted in an inner gimbal or ring. The inner gimbal is for oscillation and an outer gimbal for a total of 2 gimbals. The outer gimbal or ring, which is the gyroscope frame, is mounted so as to pivot about an axis in its own plane determined by the support. This outer gimbal possesses 1 degree of rotational freedom and its axis possesses none. The next inner gimbal is mounted in the gyroscope frame, which is the outer gimbal, so as to pivot about an axis in its own plane, that is always perpendicular to the pivotal axis of the gyroscope frame. This inner gimbal has 2 degrees of rotational freedom. The axle of the spinning wheel defines the spin axis. The rotor spins about an axis, which is always perpendicular to the axis of the inner gimbal. So the rotor possesses 3 degrees of rotational freedom, and its axis possesses 2.
First degrees of rotational freedom as rotor self-rotate. Second degrees of rotational freedom as First inner gimbal rotate around second inner gimbal, third degrees of rotational freedom as 2 same inner gimbal rotate around outer gimbal.
If you have ever played with toy gyroscopes, you know that they can perform all sorts of interesting tricks. They can balance on string or a finger. They can resist motion about the spin axis in very odd ways. But the most interesting effect is called precession. This is the gravity-defying part of a gyroscope. Precession. The wheel responds to a force applied about the input axis by a reaction force about the output axis. The behavior of a gyroscope can be most easily appreciated by consideration of the front wheel of a bicycle. If the wheel is leaned away from the vertical so that the top of the wheel moves to the left, the forward rim of the wheel also turns to the left. In other words, rotation on one axis of the turning wheel produces rotation of the third axis. A gyroscope flywheel will roll or resist about the output axis depending upon whether the output gimbals are of a free or fixed configuration. The center of gravity of the rotor can be in a fixed position. The rotor simultaneously spins about one axis and is capable of oscillating about the 2 other axes, and, thus, except for its inherent resistance due to rotor spin, it is free to turn in any direction about the fixed point. The ability of a gyroscope to defy gravity is baffling. This mysterious effect is precession. If you have a spinning gyroscope and you try to rotate its spin axis, the gyroscope will instead try to rotate about an axis at right angles to your force axis.
The gyroscope is spinning on its axis. A force is applied to try to rotate the spin axis. The gyroscope is reacting to the input force along an axis perpendicular to the input force.
The cause of precession. Why should a gyroscope display this behavior? It seems totally nonsensical that the bicycle wheel's axle can hang in the air like that. If you think about what is actually happening to the different sections of the gyroscope as it rotates, however, you can see that this behavior is completely normal. When the force is applied to the axle, the section at the top of the gyroscope will try to move to the left, and the section at the bottom of the gyroscope will try to move to the right. If the gyroscope is not spinning, then the wheel flops over.
As forces are applied to the axle, the 2 points identified will attempt to move in the indicated directions.
If the gyroscope is spinning, think about what happens to these 2 sections of the gyroscope. Newton's first law of motion states that a body in motion continues to move at a constant speed along a straight line, unless acted upon by an unbalanced force. So the top point on the gyroscope is acted on by the force applied to the axle and begins to move toward the left. It continues trying to move leftward because of Newton's first law of motion, but the gyro's spinning rotates it.
As the 2 points rotate, they continue their motion.
This effect is the cause of precession. The different sections of the gyroscope receive forces at one point, but then rotate to new positions. When the section at the top of the gyro rotates 90 degrees to the side, it continues in its desire to move to the left. The same holds true for the section at the bottom. It rotates 90 degrees to the side and it continues in its desire to move to the right. These forces rotate the wheel in the precession direction. As the identified points continue to rotate 90 more degrees, their original motions are cancelled. So the gyroscope's axle hangs in the air and precesses. When you look at it this way, you can see that precession isn't mysterious at all. It is totally in keeping with the laws of physics.
Because of its resistance to outside force, a gyroscope wheel will maintain its position in space relative to the ground, even if you tilt it. But the gyroscope's frame will move freely in space. If you push on a point at the top of a spinning wheel, for example, that point moves around to the front of the wheel, while it is still feeling the force you applied. As the point of force keeps moving, it ends up applying force on opposite ends of the wheel. The force balances itself out.
Segways use a special solid-state angular rate sensor, constructed using silicon. This sort of gyroscope determines an object's rotation, using the Coriolis effect on a very small scale. The Coriolis effect is the apparent turning of an object moving in relation to another rotating object. For example, an airplane traveling in a straight line appears to turn because the Earth is rotating underneath it.
In the inertial frame of reference, the upper part of the picture, the black ball moves in a straight line. However, the observer, the red dot, who is standing in the rotating, non-inertial frame of reference, the lower part of the picture, sees the object as following a curved path, due to the Coriolis and centrifugal forces present in this frame.
When an external torque is applied to a spinning gyroscope along an axis that is at right angles to the spin axis, the rem velocity that is associated with the spin becomes radially directed in relation to the external torque axis. This causes a Coriolis force to act on the rim in such a way as to tilt the gyroscope at right angles to the direction that the external torque would have tilted it. This tendency has the effect of keeping spinning bodies stably aligned in space. A typical solid-state silicon gyroscope consists of a tiny silicon plate mounted on a support frame. The silicon particles are moved by an electrostatic current applied across the plate. The particles move in a particular way, which causes the plate to vibrate in a predictable manner. But when the plate is rotated around its axis, the particles suddenly shift in relation to the plate. This alters the vibration, and the change is in proportion to the degree of rotation. The gyroscope system measures the change in vibration, and passes this information onto the computer. In this way, the computer can figure out when the Segway is rotating along particular axes. The Segway has some gyroscopic sensors, though it needs some to detect forward and backward pitch, as well as leaning to the left or right, which are termed roll. The extra sensors add redundancy to make the vehicle more reliable. Additionally, the Segway has some tilt sensors filled with electrolyte fluid. Like your inner ear, this system figures out its own position relative to the ground based on the tilt of the fluid surface. All of the tilt information is passed on to the brain of the vehicle, two electronic controller circuit boards comprising a cluster of microprocessors.
When the vehicle leans forward, the motors spin both wheels forward to keep from tilting over. When the vehicle leans backward, the motors spin both wheels backward. When the rider operates the handlebar control to turn left or right, the motors spin one wheel faster than the other, or spin the wheels in opposite directions, so that the vehicle rotates.
Thus we have talked about Segway, gyroscopes, Coriolis effect. As BB-8, it is not so sophisticated as above theories and devices. We only want to help you to understand BB-8 more clearly and get more knowledge around us. Motor and own wheels make the body move. When the heavy own wheels are running, they contact with the inner of the body, making the light body shell rolling forward. Wheels run clockwise or counterclockwise to make the body forward or backward. The plate rotates to change body direction.
Just like playing the space ball.
Segway control system and gyroscopes make the head arm in a fixed tilting direction, noting fall on its face. Is it so sophisticated? Take it easy. Let's have a cup of coffee and give a summary of how does my body move. How does my head turn? The head is coupled with the head support topped by magnetic force. As the arm is made in a fixed tilting direction, the head is kept in balance. As the head rotation motor is running, the head is turning. How to remote control me? Bluetooth is a wireless technology standard for exchanging data over short distances, using short wavelength UHF radio waves in the ISM band from 2.4 to 2.485 GHz, from fixed and mobile devices.
We also have a lesson about the mobile Bluetooth and how to program Bluetooth in your own mobile. Please keep on focusing on us.
How to charge me? BB-8 needs power. The batteries need to be charged. I use wireless charging technology. Wireless charging technology. Inductive charging involves the use of an induction coil, which produces an electromagnetic field via a charging station, where energy is transferred to an electronic device, which is also equipped with a corresponding induction coil. The electronic device receives the energy from the magnetic field and then reconverts it into usable electric current, which charges the device's battery, and a second induction coil in the portable device takes power from the electromagnetic field and converts it back into electric current to charge the battery. Resonant inductive coupling, which is also called electrodynamic coupling, strongly coupled magnetic resonance, is a form of inductive coupling in which power is transferred by magnetic fields between two resonant circuits or called tuned circuits, one in the transmitter and one in the receiver. Each resonant circuit consists of a coil of wire connected to a capacitor, or a self-resonant coil or other resonator with internal capacitance. The two are tuned to resonate at the same resonant frequency. The resonance between the coils can greatly increase coupling and power transfer. Capacitive coupling, or electrostatic induction, the dual of inductive coupling. Power is transmitted by electric fields between electrodes such as metal plates. The transmitter and receiver electrodes form a capacitor, with the intervening space as the dielectric. An alternating voltage generated by the transmitter is applied to the transmitting plate, and the oscillating electric field induces an alternating potential on the receiver plate by electrostatic induction, which causes an alternating current to flow in the load circuit. The amount of power increases with the frequency the square of the voltage, and the capacitance between the plates, which is proportional to the area of the smaller plate and inversely proportional to the separation. Capacitive coupling has only been used practically in a few low-power applications, because the very high voltages on the electrodes required to transmit significant power can be hazardous, and can cause unpleasant side effects such as noxious ozone production. In addition, in contrast to magnetic fields, electric fields interact strongly with most materials, including the human body, due to dielectric polarization. Intervening materials between or near the electrodes can absorb the energy, in the case of humans possibly causing excessive electromagnetic field exposure. However, capacitive coupling has a few advantages over inductive. The field is largely confined between the capacitor plates, reducing interference. Microwaves. Power transmission via radio waves can be made more directional, allowing longer distance power beaming, with shorter wavelengths of electromagnetic radiation, typically in the microwave range. A rectenna may be used to convert the microwave energy back into electricity. Rectenna conversion efficiencies exceeding 95% have been realized. Power beaming using microwaves has been proposed for the transmission of energy from orbiting solar power satellites to Earth, and the beaming of power to spacecraft leaving orbit has been considered. It is a far-field method which achieves longer ranges, often multiple kilometer ranges. Do you understand these 5 questions? I know they are hard to understand, and my knowledge is just so-so. However, I hope you view twice of this video to have a deep learning.
BB-8 is elegant, but her learning is unlimited. When you get her learnings, you will not only play well with her, but also you will be on cloud 9. Thank you for watching this episode. Welcome to Camellia Cafe. More interesting products and learnings, please visit www.camellia.xin. Your precious ideas will improve our products and service greatly.